Awesome. All right. A little tired. I can see it setting in. Um, that happens. Actually, you'll find how to work, operate, and behave sort of in a mental neutral as you the longer you're here at the school. It's I refer to the students as art zombies because that's what you guys do is kind of eat and sleep and create art. So you just learn how to operate at maximum efficiency so you don't waste a lot of time with other stuff. But that's okay. That's the way it goes. But what I would say is something to bear in mind is you guys will be in school here for about 2 years, and then that stops. Okay? It ends. You're not in school here anymore. I work here. It's not going to stop for me. So you got to feel for me too. But the good news is, like I said, it's this is a tough schedule. It's an exhausting schedule. But if you can handle this, you can handle anything. Because the work world is not anywhere near as bad as this all the time. It's true, there are crunch times. I don't know, how many of you guys have ever heard of crunch time? A couple of you? Okay, that happens in the industry a lot. You get to the end of a project, with many people making creative decisions, there's always changes. And what that means is you're going to be doing a lot of work at the very last minute, like crazy hours. But like I said, if you can handle this here, you're going to be fine. In fact, when you talk to people who work in the industry, they talk about Full Sail grads and what they're good at, what they can and can't do. What they say a lot is they're very self-reliant. Full Sail students can do anything. When they get out of here, they can fix, resolve, troubleshoot. They can handle that all on their own. Very independent, which they love. And the other thing, good work ethic. Go, go, go. Get it done. And honestly, those are probably things we can't really teach you. That comes from you. You know, you decide I need to change my work ethic. I need to take on this new personality of this artist for hire, and that's the way this world works in terms of this industry. So definitely handy for you to learn those kinds of things. And I hope you're picking that stuff up. You guys feel like you're adjusting a little bit? Okay, like I said, it's not an immediate thing, but you got to kind of get used to that. But you get better at it as you go. And incidentally, just to throw a little bit of excitement on your fire there, do you know what today's lecture is? You know what number it is? 5. How many lectures do we have? 11. We're basically halfway done with this class. Does it feel like halfway? Is that crazy? It goes, and the reason I draw attention to this is because time here at Full Sail goes very fast. You're really tired? Yeah. There's a lot to do and not much time to do it. But what does not change is how quickly the classes go by. Because literally, you think a month is a long time. We're at the halfway point, right? You're halfway done with this class. So time goes by very, very, very quickly here. So make sure you're making good use of the time you have here. Take tremendous advantage of all of the teachers who work here and how much they love what they do and how much they can help you. And all these awesome people you're surrounded with. You'll probably not be surrounded by so many people creatively driven like this again. So make sure you're making friends and getting to know other people, even other programs and stuff, because there's all kinds of terrific contacts that can take place as a result of these relationships that will develop between you and other artists. So, like I said, time goes by really fast in here. I feel like it's a time-space continuum issue of some kind, because I've been working here for about 800 years, and it doesn't feel like that at all, because it goes so fast. But like I said, take good use of the time you're here. It's really a unique place. You'll not find that again. All right, so let's talk a little bit about Lecture 5, the almost halfway point of the class. Today we're going to be talking about all kinds of fun stuff to help speed up your workflow, speaking of time. The reason being, modeling is modeling, and we've pretty much shown you everything you need to know in terms of how do I model something using polygons. But what we need to learn is more tools, more techniques. We're going to learn better and faster ways to do things because, as I have said previously, great looking art is the given, unfortunately. You would think, oh, the art, look at that. That's what's expected. That's the given. The speed and quality at which you can execute is the part where we're going to work on because that's the part that they're trying to discern. Yeah, they're great artists, but how fast can they do it? How well can they do it? Can they follow instructions? Do they work well with a team? These are the variables that you wouldn't think make a big difference. All the difference in the world. All the difference in the world. So let's work a little bit today. We're going to talk again about some cool and smart techniques and tools you can use to speed up your workflow, help you get things done faster and more efficiently, because we're always going for that. We'll also delve into some more vocabulary things. We're going to talk about some stuff like deleting history and freezing transformations, which are very critical to your modeling process. And then we are going to delve into, we're going to be getting into some hierarchy stuff. We're going to be getting into some of that stuff like, for those of you who have heard of or are interested in setup or rigging as a process, where we make the skeletons that allow us to bring things to life. We're going to be talking about hierarchy and chain of command and all that, so you can understand the very foundational steps of rigging and hierarchy. And we will also get into pivot points and how we can move those, because that's actually a really helpful thing to be able to manipulate those. Again, speeding up and being more efficient with our workflow. All right. Oh, let me move this thing over. No, I guess you don't see that. All right, first thing, vocabulary. Anytime we see the periwinkle vocabulary thing, that's something that's on the self-grade document. This particular vocabulary element, deleting history. Excuse me. Deleting history is very important because what happens is while we are working, Maya is basically writing down everything we do one step at a time. Computers are great at keeping track of things. So here's what Maya is doing. It's like monitoring us and writing down everything that we do one thing at a time. Now that's, most of the time it's not all that helpful. Every once in a while, having access to the history is kind of cool, and it's to our advantage to do so. But for the most part, that huge buildup of history, more often than not, leads to problems, not things that help you. Issues that you run into is files can become corrupted, tools don't work quite right. There's all kinds of stuff that happens because we're forcing Maya to remember a lot of information that's not really that important. So something that we do periodically while we're modeling is we delete history. And for me, as I said, it's a good idea to save quite often. How often did I say to save? About every 15 minutes is when you should be saving. And what I typically do is freeze transformations, delete history, and save the file. And then what I've done is saved a clean copy of the file. But what's very important for you to understand is deleting the history does not mean you have lost the process of using the undo. They're not related. Undo is a process where we go backwards a step. So literally, if you delete the history on an object and you hit undo, the history comes back on. So there's no, I can't undo things. That's not a thing. So deleting history is a great idea. Again, I call it sort of a house cleaning thing, but it's something you need to do to keep your geometry clean and efficient, keeps your files happy and functioning, and all of your tools work great. So a lot fewer problems as a result of doing that. Typically when a student tells me, hey, my file's going crazy, I can't open it, there's like demon heads in there and they're spinning around and they're speaking Latin backwards and I'm afraid what's wrong with my file, one of the first things I will do is, first I'll ask if you've restarted Maya recently, because that's always a big ticket item. But then the next thing I say is, excuse me, is there any history on your geometry? Because that can lead to these kinds of issues. So let's take a look at that process and how it works and why we do it. So here's Maya, and let's say I've got this object, and I use a tool on it, like say the inserted edge loop tool. I drop in some edges here. What you will notice is when I select the object, I have the name of the object and its transformations over here, and here you will see a series of things that have happened to this object. And basically it's the object's history. And it'll have stuff like first steps, first word, crawling, tummy time, like all that stuff is listed here. Not important. I don't really need it. So what I'll do periodically is just clean that up. Again, I do it every 15 minutes. The steps for deleting history are these. Number 1, select the object in object mode. Got to be object mode, got to be selected. Go to Edit, Delete by Type, History. All right, very straightforward, very simple, but very important, easy to overlook. So you delete the history and watch what happens, because you'll look over here and you'll notice that suddenly these things will be gone. Gone. So when I select the object, there's no history there. Does that make sense? Deleted history. Now, if I gave you guys instructions on how to do that, and I gave it to you as a little periwinkle thing, is that something you think I'm grading on? Yeah, for shizzle, right? So make sure you're deleting history on your geometry. You could do it while you're working. You can wait till the end. I don't recommend it. I recommend doing it every 15 minutes when you're saving. And can you do many things at once? Yeah, you can select everything in the scene and delete the history on it if you want to. So you can do it. But I would recommend selecting the geometry afterward and make sure it did it. Does that make sense? Because, you know, what we think Maya is doing and what Maya is actually doing sometimes, ne'er the two shall meet. Yeah?
So if it's so important to not have it, why does Maya keep track of it?
That's an excellent question, and I'm really hoping at some point today, because we have a couple of things we're going to do, where history is actually very helpful. But one instance which we won't touch on in this class where history is actually very helpful is the process where we bind geometry to a skeleton when we're going to animate it. We were talking about rigging a little earlier. Binding geometry to a joint in the skeleton is actually related to history. So if you delete history, the geometry will not follow the skeleton. So in some instances, and that's sort of a vague reference because we haven't even gotten into that kind of thing yet. But point being, some processes rely on history being there, but during the modeling process where we're building, I don't need it. Does that make sense? So sometimes it's very important, other times not. But thank you for asking. That was a great question. How many of you guys are excited he asked that question? You see? That's why I say ask questions. All right, let's get back to our slides. Delete the history. Okay, let's talk about modeling smarter, not harder. So if you have the option of staying up all night or just doing things a little bit smarter, let's do things a little bit smarter because staying up all night definitely has diminishing returns. So what I'd like you to do is when you are modeling objects that exhibit some measure of symmetry, meaning it looks similar from one side to another, you know, bilateral symmetry, this side looks like that side, or you see repetitions in the patterns, start to look at, well, how can I save myself some time by modeling just part of something and then duplicating that in a special way to where we end up making the whole object by only having to make a tiny bit of it. And that can speed up our modeling process. To do that, we're going to use a fun little tool called the mirror tool. And if you look under Mesh, it's hidden down here, mirror geometry. Well, actually, it's just mirror now. They took geometry off. But what it does, basically, it allows you to take a look at an object and model just one side of it and duplicate it to the other side, right? How many of you guys draw? Illustrators, artists? Awesome. This is a good class. Lots of drawing. Good. Don't ever stop doing that. In terms of drawing and illustration, how brutal is it in terms of trying to make one side of an object look like the other? That's the worst, right? That's like one of the few reasons we decided as artists, okay, we'll let machines in because we can make one side of something and we'll let the computer make the other side. So I don't have to do that. So again, what happens is I can make half of something and then I can have Maya make a copy of it on the other side and it's a perfect duplicate. And again, that's what that mirror tool is for, and it's super fun. So what you have to do is take a look at the objects that you're trying to build and just say, well, you know, are there elements of symmetry here? Oh yeah, you know what? This side of the mailbox looks like that side of the mailbox. This side of the mailbox looks like the other side of the mailbox, with the difference being that handle and that little opening area there. But you know what? I could mirror that first because the front looks enough like the back, and then put this detail in afterward. Does that make sense? Save me a lot of time. So some of the things we can think about is how can we use that tool and model smarter. All right, and you know this means we have a fun activity to do, and you probably can guess it's probably called the mirror activity, right? So we're going to make sure we set our projects to the activity file folder. So file, project, activity files, and then file open scene, and then I'm going to go to my mirror geometry activity. Boop. All right. So what happens here is I have basically a quarter of this mailbox built. And if you look at my reference image, you can see one side of this mailbox looks like the other. One side of this mailbox looks like the other. So I can just mirror and basically build like just a corner of this thing, and I can build the whole object from it. Now, it's something to bear in mind, though, that I want to make sure of that you understand. When it comes to modeling, we're talking about shape and form, right? Do you think it makes a difference that my reference image, the mailbox looks like R2-D2 in the side view, but it's just blue in the other view? No, that doesn't really affect anything because I'm looking at shape and form, right? So the fact that the reference looks different, as long as it's the same kind of mailbox, it doesn't matter what texture is on it. Although the R2-D2 one is really cool, that doesn't affect my ability to model it. But when I get to the texturing phase, maybe I want to make it R2-D2. So, all right, so let's take a look at this tool, how it works. And I'm going to hide my grid here. And actually, I'm going to hide my image planes. That's more important that I hide, just because I don't want you to be distracted by the pictures. So I'm going to hide those guys by unchecking them. And what we're going to do is talk about the mirroring process and really the important parts that we have to remember. Now, in terms of mirroring, what we want to make sure of is that our geometry is all on one side of a line here. And this is the grid line that runs down the middle of the world that I'm building. And of course, my object is resting on the surface grid line of the world I'm building. But what we want to do when we're mirroring geometry is determine A, where my geometry is, and B, which direction I want to mirror my geometry into. And the reason this can become confusing is oftentimes a student will decide, okay, left is Z, right is X, you know. You have to get that out of your mind because that's got nothing to do with it. You have to look at the orientation of the grid. And in terms of what's going on here, we know Y is this way because we've got the green arrow and it's pointing up. This is positive Y. So this way has to be negative Y, right? Because we're going down. Make sense? So look for the arrow for is it positive or negative, and look for the color for what axis it's on. Don't try to figure out left and right because your perspective may be wrong. All right, so in terms of this object, my geometry currently exists in positive Z. I know it's Z because the arrow is blue. And I know it's positive because this is the direction the arrow is pointing. So when I want to mirror it, I want to send it to negative Z. Does that make sense? Again, I want it on this side. So in terms of the mirroring, these are the steps. 1, select the geometry in object mode. Got to be selected, got to be object mode. Go to mesh, and you will see mirror. And of course, we have to go to the options box. We open that up, and here's where we tell it where to mirror. So my object is currently in positive Z, so I want to send it to negative Z. So I make sure I've checked the Z axis to mirror on, and the mirror direction, I want to make sure it's on negative. So it's going to negative Z. I'm also combining the objects together. Oddly enough, sometimes you don't want the pieces of geometry to fuse together. But I want them to fuse in this instance because it is the single material. So then I hit apply. And what happens is, like magic, I now have half of my mailbox. Now, luckily, that little history demonstration I wanted to give you, it happened. Sometimes it does and sometimes it doesn't. Here's my object before I mirrored it. Here's my object after I mirrored it. What happened right there? Is that the way the mailbox should look on the top? No. What happened? Anybody? Problem with the threshold. When I had those two objects combine, when I had them merge into one thing, right? We know that if we've got vertices on both objects, what do we have to do with those vertices? We have to merge them together, right? Remember the merge geometry tool? We talked about the merging the vertices. And threshold was the most important part, right? We talked about how far vertices are from each other and how they fuse together. Does that make sense? So my issue here is some vertices on both sides of this object were close enough together that they just merged together. And we've determined that that is a function of threshold, right? So if I don't want vertices to merge together, do I use a big number or do I use a small number? How many of you think it's a big number? How many of you think it's a small number? It is a small number. You want to have a nice small number because I only want the things that are very close together to stick together. Things that are far apart, I don't want them sticking together. Just the stuff that's very near each other. So in this instance, history is your buddy because if you look at this object, right, if I select it, you will see in its history the mirror that just happened. And if I click on that, I see the attributes associated with that mirror. What value is this? Merge threshold, 3.662. All vertices within 3.662 grid units of each other merged. That number is way too big. What's a good small number for me to plug in there? 0.001, a really small number, right? So even though this has already happened, this is a thing, I can change my threshold 0.001 and fix it. So sometimes history's your buddy, most of the time not. But does that make sense? You can't go back in time and find Sarah Connor. But there are repercussions. Much like if you change history, things in the future may be different. Right? So, you know, you don't let the Library of Alexandria burn down and then all of a sudden in 1492 we're going to the moon, not just the new continent. Anyway, point being, in terms of history, in some instances, if you change history, you do terrible, irrevocable damage to the future. And that will happen with your geometry too. It'll literally just come apart. Yes? Did it? I'm sorry. But that was a big deal. That was quite a devastation in human history when the Library of Alexandria burned. There's a lot of information there we lost. Thousands of years. Took us a long time to catch back up to that. Interesting thought. Although, on a reassuring side, I would say, as a species, humanity was not ready for travel at that point. I don't think we were bright enough. We were not, you know what I mean? We needed to evolve some more because there's a lot of responsibility on interstellar travel. You know what I mean? You have to be in a good place where you are before you can go somewhere else. Well, I was thinking more from the standpoint of making sure you don't spread, you know, germ disease and problems throughout the universe because you don't understand the prospect of quarantine. You know, I mean, the concept of treating one another well is beyond you. You know, forget worrying about other worlds. You know, that's more what I was thinking. But that's an interesting thought too. But yeah, why bring war to the universe? But anyway. So yes, it's discouraging on one level, but I don't think we would have been ready for it then either. Probably, we still need to evolve before we can do that. That's just my thought on that, though. Anyway, so we can see in this instance, getting rid of the history is our buddy, or being able to adjust the history is helpful. All right, let's take a look. Here's another little thing. So now I've mirrored left to right, right? I've got that. Or I've mirrored front to back. Now I can do left to right too, but I'm not going to tell you the answer to this one. You're mean. Maybe a little, but it's because I care. So you guys tell me, I want to mirror this piece of geometry. What axis is my geometry in? Go ahead, don't be shy. It is in X, absolutely. Is it in positive X or negative X? Somebody else tell me. It is in positive X because here's the arrow. It's red. That's what tells me it's X. And the arrow is pointing this way, so my geometry is in the positive. So when I want to mirror it, where am I sending it? Negative X, right? So, same process. Select the geometry in object mode, mesh, mirror, and I want to change it to X-axis, and I still want it to be negative because I want it over here. So I hit apply, shabam. Now I got another one of those bad boys. All right, so now I was able to like mirror the entire mailbox, no prob. And now I can go in and make the details that are on that specific side that are not on the others. Make sense? Hell yeah? Okay, good. So mirror geometry. Hey, we kind of like that tool. Okie dokie. Let's take a look at another super fun tool. Duplicate with transform. Duplicate with transform. Uh-oh. That sounds scary. What's duplicate with transform? Duplicate with transform is the idea that we can duplicate geometry and, don't act now, we can also include transformations. And what that means is we can basically duplicate something and move it. And Maya will not only make a duplicate of the object, but it will also remember how much we moved it. And it will incorporate that information into each subsequent duplication. Now, where this comes into play, you guys know what the spokes of a bicycle look like, right? Right? If I've got a bicycle with tons of spokes, you know I got to model those one at a time. No! Yes. One at a time, I'm going to model those spokes. How much of a drag would it be to make a spoke, duplicate it, turn it a little bit, duplicate it, turn it a little bit, duplicate it, turn a little bit, and make the 9,000 spokes you have to make, right? You'd go crazy. But this duplicate with transform tool, you can make one spoke, duplicate it, and move it a little bit, and then make a whole bunch of duplicates, and each one will move the right amount so that they will be perfectly spaced. Right? Tanks on a tread, anything that's repetitive. Tanks, scratch that, make it the other way around. Treads on a tank. Yeah, no, I just, but yeah, if you look at a tank tread, it's a series of interlocking pieces, right? Or really nice watches. Now I gotta make tanks on a tread. Okay. Shoot. I hate when I do that. No worries. But anyway, in terms of this tool, oh, what a tremendous time saver it is. So let's take a look at how this guy works. It's super fun. In terms of the duplicate transform, we can incorporate both the moving and the duplication aspect. Now, for this exercise, I want you to remember these numbers because you're going to need them when we duplicate the steps. Translate X, the value is 0.3. So you'll enter that value and hit enter. Remember to hit enter, that's the key. Translate Y, 0.3. Again, you'll enter that value and hit enter. And then you rotate Y 7 degrees. 7 degrees of rotation. Again, hit enter after each one of those. All right, so let's do that exercise. Duplicate with transform. So I go to File, Open Scene. Where are you? And then I'm going to do my duplicate with transform. All right, and what I've got is a step. That's it. And what I'm going to do is go to Edit, and you will see Duplicate with Transform. Now, when I make a duplicate, you can't see the duplicate because they are right on top of each other. But the reality is, it is in there. They're just right on top of each other. So this is what I'm going to do. Select step number 1. Edit, duplicate with transform. Okay, so now I've done that. I've made the duplicate, and Maya is now starting to record whatever movements I do. All right, so I'm going to plug in for my x value. What am I plugging in there? 0.3, and hit return or enter. And that moves it back 0.3 grid units. My next value, translate y. What was that one? Also 0.3. And hit enter. That moves it up. And then what was my last value? 7 degrees, but on which axis? Y-axis, thank you. 7 degrees, and hit enter. And that just gives us a little bit of an offset there. Rotates it ever so slightly. So now I've got this second step in place, and I've moved it a couple times, and I've rotated it once. Now, fun thing about Maya, some tools are repeatable. You do something, and you can do it again and again and again and again. And the way you do that is through the use of a key, the G key. G as in George. G means do what you just did again. So I just made a duplicate, and I had Maya record the movement. And I want Maya to do it again, so I'm going to press G on my keyboard. So when I press G, it makes another one. And each time I press G, it makes another one. Fly me to the moon and let me play among the stars. Find out what the weather's like on Jupiter and Mars. Huh? Look at that. Watson and Crick would be jealous. Look at how fast we can do that. Press the letter G. Now, here's the issue. If you're having trouble with this exercise, more than likely, either A, when you entered your values, you didn't hit enter after each one, because you got to click the field, put in the number, and hit enter. Then click the next field, put in a number, and hit enter. The other issue that typically happens is, in the middle of the process of doing this, select the geometry, duplicate with transform, move it, move it, move it. If you click off into space, if you let go of the object, you move it up, then down, then move it to the right, and then click somewhere else, you've interrupted the workflow. Maya can't remember everything that you're doing. Does that make sense? You've changed gears. So it is of the utmost importance. It's one fluid process. So I'm going to show you again so you can see it. All right, so again, you got to select the geometry in object mode. And you'll notice I'm not going to click anywhere else. I'm not going to deselect it. Got to be selected. Edit. Duplicate with transform. I've made my duplicate. It's still selected. I'm not going to click off into space because Maya will forget what I'm doing. I go immediately to my move tool. Move it up a little bit. Again, I don't let go of it. I still have a hold of it. Maya is still recording as long as it's selected. Move it back a little bit. Now I'm going to rotate it a little bit. All right. Now, without deselecting, I'm going to hit G. And it's going to continue to make whatever it was I made, whatever adjustments. I gave you perfect values, so it was more predictable in terms of what it was going to do, but it's going to remember everything you do. Does that make sense? So whatever adjustments you make. All right, delete that one. Delete the other one. You have several on top of each other. Now grab that one. Yeah, you didn't do edit, duplicate with transform. Yeah, move it up a little bit. Move it back a little bit. Put a little rotation on it. Now hit G. Like I said, it's a touch thing. If you just click off on something else, or you have something else selected, or you make several duplicates, you don't realize it, you don't know which one you got, this is where that one comes amok. But as long as you do it like that, you're going to be fine. So duplicate with transform, that's a pretty fun one. All right, let's talk about poly counts. In our world, we love to measure things, right? Ounces, gallons, miles an hour, gigawatts. We love to measure things. So how do we measure polygon geometry? Because it doesn't even really exist. It just points in space inside of a computer. But what we can do is measure the complexity of a polygon object. And the way we do that is by counting the number of faces on the object. So, for example, as an assignment, I might be given, Steve, you have to build Ahsoka's lightsaber, but you've got to do it in under 500 polygons. So what that means is, yes, I have to build this weapon. I have to build as much detail in it as I possibly can, but I can't go over 500 polygons. So as a result, there's a ceiling. So I have to be super efficient with my model because I want to make sure I get every detail I can in there, but there's a limit. It's a budget that I cannot bend on. Because literally when it comes to building assets for a video game, there's only so many polygons that can be on the screen in order for the computer or processor to be able to calculate in what we call real time. And what that means is, if I'm playing a video game and I come into a room and I change my view, what I'm looking at, the computer is drawing for me, literally, so I can see it. And it can only draw so fast, just like you can only draw so fast. Does that make sense? 60 drawings a second for what we call real time. Does that make sense? Yeah, I wish I could draw that fast too. So don't pick on your computer. They're actually very, very good. But the point is, when you're making video games, regardless of the platform, some are faster, so you can draw more quickly, therefore higher detail. Some games are more simple, smaller processor, not as smart or fast, so it's got to be a more simple drawing. So we need to know how many polygons an object is made of when we're making assets for a video game. So it would take a really long time to count those things up, but the good news is we have a way to figure out how many polygons are on any given object. We can activate the poly count. If you go to Display, Heads-Up Display, Poly Count, Maya will list for you the number of faces, the number of triangles on any given object. And the reason there's a couple of rows, it's how many are visible, how many are selected, how many are in the shot, that kind of thing. So you can determine what's going on there. But it'll tell you how many faces, and the number of faces on your polygon object is its poly count. So if I was told to make the lightsaber under 500, I'm at 489. So I got a couple more to go if I want. Not that many, but I got a couple more. So poly count becomes a big deal. Not in this class, but in other classes it might. So just be aware. Those are part of the technical parameters that might be a part of whatever it is you're working on. Any questions on poly count? It's kind of an abstract thought in terms of processor speed and drawing pictures for you. No? Okay. Nothing? My digital friends? Nothing? Okay. Yes? Mm-hmm. Yep. Well, then you're going to have to remove some edge loops. You're going to have to get rid of some details. Yeah, it's kind of like after you're done with your drawing, now you got to go in with an eraser and get rid of some of the details. That's the equivalent, which is a bummer. But the good news is we build from light detail to heavy detail. We revisit our models in a series of passes. We're efficient with every pass. That keeps that kind of thing to a minimum in terms of that happening. Does that make sense? So a lot of these things we're talking about, you will be doing anyway, because we're trying to teach you the way to do it to avoid having to do stuff like that. Does that make sense? So again, when you're modeling the way we show you to do it, it's going to be better for you. You will have fewer of these kinds of problems. But that's what you would have to do, is remove some edge loops. get some detail out of there. Good question, though. All right, let's talk about pivots. All right, this is a vocabulary thing, so again, you know we're going to be asking you about it on your self-grade document, making sure you're doing that with your project. Pivot points. Pivot points affect the functionality of objects. And we are going to build functionality into the stuff we make. That's important. It has to work. Now, in terms of pivot points, what we're talking about is where things move from, right? So if I've got a pair of scissors, the pivot point is where the blades cross, right? There's usually like a rivet or something there that holds the blades of the scissors together. And when I use the scissors, they pivot on that point. If the pivot point is somewhere else, the scissors don't work right. Okay? Now, in terms of pivot points and functionality, if you guys look at that door, the door to our classroom, do you know which way it opens? Which way does it open, in or out? Out. It definitely opens out, right? That's an OSHA rule. You can't have doors that open in where lots of people meet. It's a fire safety thing. But in terms of that door, it definitely does open out. And I know that because I can't see the hinges. Where the hinges is what determines which way the door opens, because the hinges will always be on the side that it opens outward to. Does that make sense? Because they pivot on the hinges. So when we are building objects and we need them to move, and we do, we have to make sure that the pivot points are in the right location to get the movement we want out of it. Does that make sense? Okay, so when we're talking about pivot points, we need to make sure they're in the right place. And incidentally, with this staple remover, you know, obviously what we're talking about, it should pivot from right there in order for that thing to work right. So let's take a look at pivot points and how they work, because they're just too dang fun. All right, our project is still set, so we can go to File, Open Scene, and I'm going to go to my, which one is it? Duplicate with transform. Oh, Edit Pivot Point, that's the one. Open. All right. Now, in this Edit Pivot Point activity, we have two doors. One is a very funky looking, exciting one, and one is really very boring. But that's okay. Gesundheit. In terms of the pivot point, Maya by default puts the pivot point kind of in the middle of the object. So if I select an object and I go to one of my tools of manipulation, you'll see that the pivot point for that object is kind of in the middle. All right, and then that determines where it pivots from. So if I try to spin this door, if I grab the y-axis, you'll see it's pivoting from the middle. All right, but and it's true, there are some doors that pivot like that. I've been to places where they have these kind of doors that spin around, and there's always, you know, that little fear that you're going to get caught in it, or somebody's going to stop pushing and you're going to get stuck in there, or, you know, not for very long, obviously, but so. There are doors that spin like that. But let's say I don't want it to spin like that. I want it to open like a regular door. Well, what I'm going to have to do is edit the pivot point. I want to move it somewhere else. Now, if you look at your keyboard and just regular letters, you'll see the D key. D as in David deactivates your pivot point so you can move it. Because if you leave it like it is and you try to move it, the whole object moves. But if I hit D on my keyboard, as in David, now I can move the pivot point, but the object doesn't move. And what I'm going to do is I'm going to move my pivot point to the edge of my door where my hinges should be. And it's a really good idea to use your orthographic views to do this, because you can be more accurate with your placement. And I got that pivot point right on that line here in terms of my front view. And then I'm going to come up here, and I'm going to move those hinges so that they are on the outside of my door, because I want this door to open in this direction. So I've got that there. Now, once you've got your pivot point where you want it, then you got to hit D again, as in David, and that's going to sort of lock that pivot point where you've put it. And now, and forevermore, when you select this object, it will always pivot from right there. And now it swings like a regular door. Does that make sense? Okay, so here's what I want you guys to do. And Brian and I will walk around and check on you as you do it. You look at this door right here, you'll see it's spinning from the middle, which is no bueno. What we'd like it to do is pivot on these hinges, as it should. And also, you've got this locking mechanism and this handle, and you can see that's not pivoting from the right place, and this handle not really pivoting from the right place either. So you're going to have to adjust the pivot points of the locking mechanism, the handle, and the door itself. Now, you will notice that when you work this door, the locking mechanism and the handle will not move with it yet, but we're going to talk about how to do that next. But first things first, we adjust the pivot points. So let's walk around and see what's going on. Make sure everybody can move their pivot points. D as in David. Good, good, good. How's it going? Good. Okay. And make sure you're selecting these objects one at a time, because if you select several objects, you're going to be moving the pivot points of those several objects. You want to pick them one at a time and make adjustments. There you go. And you got to hit D on your keyboard as in David. Then you can move it. Grab the arrows. Grab the arrows of the pivot point. There you go. There you go. And like I said, use your orthographic views. It's much easier to get a really good placement of those pivot points. Make sure you're hitting D on your keyboard. Oh, there you go. Yeah, you got that centered. Good. You have to select it in object mode. Yeah, hover your cursor over the geometry and hold down the right mouse button and choose object. Upper right. There you go. Now you can see your pivot point. So now if you press D on your keyboard, you can move that pivot point. D, there you go. Grab the arrows. There you go. Good, good. How are you guys doing back here? My back row hiding people. Yep, then hit D again, and then now that should work. Good. The door, the handle, and the locking mechanism. Yeah, there's a little spinning thing with spiky handles sticking out of that thing. Yep. Make sure you get that pivot point over on the hinges. Yeah, that one you're going to want to get the pivot point right in the middle of that so it can spin. Because that should turn in a circle. You got it? Select it. All right, the pivot point is way the heck down there, right? It should be over there. So you're going to press D on your keyboard. That's right, get out of that menu set, you're good. Select just the handle. Hit D. Now grab the arrows and move the pivot point so that it pivots where it should pivot from. All right. How's it going? You have to hit D on the keyboard, and then you'll have arrows. If you need to make them bigger, use the plus key on your keyboard. How you guys doing? Good? Good. Awesome. Good. All right, very good. Seems like you guys are doing pretty well with this. Again, it's fairly straightforward. We're moving the pivot point so that objects move based on where that pivot point is. Because like I said, with scissors, it's very specific where that pivot point needs to be in order for them to function properly. All right, so again, as I said before, you're probably going, okay, great, the handle is moving, the locking mechanism is moving, the door pivots from the hinges, fabulous, but why don't the handles and the locking mechanism move with the door? Well, here's where we're going to talk about that. So don't lose this file. We are going to pick it up where we dropped off, and we're going to talk about how to get those things to move together. But first, we have to have an important discussion about something called hierarchy. Hierarchy, what? There we go. Boop. Hierarchy. Hierarchy is the idea behind how we get things to move together. All right? Now, making things move together is, again, it's the basis of making everything move in Maya. We have to establish a hierarchy or a chain of command to determine who tells who what to do. Now, in terms of hierarchy and chain of command, how does that work? You can think about your own world, right? Your family tree, right? We got grandparents, they tell the parents what to do. Parents tell the kids what to do. The oldest kid tells the youngest kids what to do. So there's a hierarchy, there's a chain of command. The key elements are, there has to be a clear chain of command in order for you to do something, and there also has to be only one set of instructions. Like your mom and your dad might be the same level on the hierarchy, but if one of them tells you to do one thing, mow the lawn, the other one tells you to do something else, wash the dishes, you can't really do that. You got two sets of instructions from two different places. So the key is I've got to have a clear hierarchy and one set of instructions, and if I have that, I can do it. And that's the whole basis of movement in Maya. So let's look at some ideas of hierarchy in Maya. Incidentally, this is a hierarchy is obviously a vocabulary element, but in terms of hierarchy, you can see these icons here. These are called nodes. Maya is a node-based application, and you can see how these nodes connect to each other, and they establish a hierarchy, or like a family tree, a chain of command. In terms of node-based, what the heck does that mean? How many of you guys have used Photoshop? Okay, Photoshop is a linear application, right? Everything is a straight line in terms of what's happening thought process-wise. When you're looking at the layers in Photoshop, it's basically like looking down on a bunch of sheets of paper. Each layer is a sheet of paper, and you can have those pieces of paper affect each other or not, depending on what they're set for. But you're looking down on a whole bunch of images that are brought together to represent one final image. Again, it's linear in its thought process. Maya is a node-based application, and what that means is we're not looking down on an image. It goes in every direction. So we're not looking at pieces of paper attached to each other. We're looking at stuff that builds in any direction we want to go to, and they're all connected to each other. Think of like Legos, or Lincoln Logs, or erector sets, or what's that other one? Tinker Toys, right? You have a few different things, and they can connect in any such way, any direction. It's not linear at all. It goes in all directions. But let's talk about some ideas of hierarchy and chain of command. All right. Here's a cube, and here's a sphere. All right. Now, when I select objects in Maya, they light up green. If I select more than one object in Maya, you'll notice that the last one is green and the other ones are white. That's because of something we call selection order. I selected this last, therefore it's green, the others will be white. In some instances, that's actually very important, which item you selected last. All right? Now, when I select two items, one of them will be green and one of them will be white. You'll also notice, if you look in the channel box, the objects are listed as the name of one of the objects and ... It doesn't include everybody. It just mentions at least one of them and says there's also more than that selected. Now, in terms of nodes right? And those nodes I was talking about, if you want to see them, if you go to Window, General Editors, Hypergraph Hierarchy, you'll actually see a window in Maya that shows you the nodes or the icons for the objects that are in your scene. And that little picture on the end, that means polygon geometry. That's what it's telling you what it is. I could select an object here, and it lights up there. Or I can select the node in here, and it lights up out there. The hypergraph hierarchy is an orthographic window. And just like all windows in Maya, they're showing you the same thing, just from a different perspective. We're looking at nodes. All right? Now, when I select both objects, again, one's green and one's white, but they are both selected. And again, they don't get all of their names in there. It's dot, dot, dot. Does that make sense? Okay, let's look at how they move. In terms of these two objects, they move together when you translate them, right? They scoot along next to each other. But watch what happens when I rotate them. When I rotate them, you'll notice they do rotate at the same time, but they are rotating from their own pivot points. They have a sense of self. Does that make sense? It's an individual identity. Now, here's where it gets interesting. If I want these two things to move together, I can actually change the way they move and the way they behave by using a process called grouping. Grouping. In our world, when we think of grouping, we group things usually visually. These are colors that I like. These are cars that are very fast. These are kinds of pizza I'd like to eat. You know, that's how we usually group things. In Maya, we group things by creating a physical relationship between the objects. But what's tricky about it is you can't see it. It's invisible, like love. But the point is, there's definitely a relationship between these objects, and it governs the way they move. So, this is the way I'd like you to think of it. Imagine I have these two objects, and I want them to move together. So what I'm going to do is group them. Grouping, as I said, is not something you can see, but it is physical. What we are talking about is creating, basically, an invisible box. And it governs the way these things move. So I can take these two objects, and I'll say, you know what, I'm going to now group you. They're now grouped. They're in this invisible box. They can move in the box all they want. I can move them in the box, but as soon as I pick up the box, they have to go because they're in it. And again, they can move inside the box. That's fine. But wherever the box goes, they have to go because they're in that box. Does that make sense? Okay, let's take a look at grouping. Kind of, yeah. So I select the objects, and I go to Edit, and I choose Group. Now, a couple of things are different. Who can use their keen eye of observation and tell me what's different about these two objects now? Because I have two of them selected. They're both green, right? That's different. So you know right away something's different here. What else? Pivot point is here. A little hint. You make something new in Maya, the pivot point's usually at the origin. There's one more thing that's different. What's different? What does it say in the channel box? Group 1. Does it mention the sphere? Does it mention the cube? No. Only group 1. Let's watch how they move. They move together, right? Like we were seeing before, but watch what happens now when I rotate them. Are they rotating in their own space? No. They're pivoting around this pivot point here. Let's take a look at the hypergraph hierarchy. You can see the group is in charge of the cube and the sphere. Wherever the group goes, the cube and the sphere must go. The cube can move on its own. The sphere can move on its own. Right? The sphere can move on its own. The cube can move on its own. But when you select the group, they have to go as one. Now, in terms of groups, I can take things out of a group if I want to. If I hover my cursor over any node in the hypergraph hierarchy, hold down the middle mouse button, I get the green plus of power. And I can drag off into empty space and let go. And it disconnects a node from a group. So now this guy is all by himself. I can grab the group, and you see the cube or the sphere is still moving with it. But the cube does not. Similarly, when I grab the group here, the sphere moves, and the cube does not. Same thing when I rotate it. If I'd like to add the cube back into the hierarchy, I can do that. If I hold down the middle mouse button and get that green plus of power, I can drag to the group and let go, and that reconnects it. And now again, they move together. They move together. They move together. Does that make sense? I've reestablished that hierarchy. I can add things to hierarchies or take them out if I want to. Window, general editors, hypergraph hierarchy. Hypergraph hierarchy. All right? And that lists everything that's in my scene. Now, interestingly, if I want to delete an object, I can select a single object and delete it. But if I grab the group and delete it, everything in its power goes away. Everything it has control over, gone. Also very interesting, when I select objects, they light up. Right? If I select the group node, they light up, but are they really selected? They're both lit, right? Like they're selected. But are they? They're not. That's because if you select something and there are objects in its hierarchy, they light up. It's sort of a rule of hierarchy. It says that, oh, this thing is in charge of us. So you can see the hierarchy. Does that make sense? Okay. That's grouping. One way to make things move together. Let's look at another way. Here's our sphere. Here's our cube. Let's look at another process called parenting. And as you would think, it's about being a parent. One object is the parent, and the other object is the child, or objects. You can have many children, but only one parent. Yep, just like the real thing. It can be proven. All right, so in terms of parenting, you have to establish which object is the parent and which object is the child. So if I want the cube to do what the sphere says, the cube is the child and the sphere is the parent. When you create a parent-child relationship, you always select the child first. This is where selection order becomes a big deal. You have to select the child first. In fact, if you selected 50 things, 49 of them would be child of the 50th. Whatever's last is the parent. So if I select the cube first, shift select the sphere, edit, and then parent. Now I've established another relationship between these objects. The cube is the child, does not influence the sphere at all. But when I grab the sphere, both of them light up. Does it mention the cube at all? No, channel box only mentions the sphere. The sphere is absolutely and utterly in charge. Wherever the sphere goes, the cube must go. Child must follow the parent. And in terms of rotation, the cube, or the sphere, is the child's world. It's just going to follow the parent no matter what. And in terms of that hypergraph hierarchy, you can see the cube does what the sphere says. All right? And again, they're both lit, which you would think would indicate they're both selected, but they're not really. Just the sphere is, because of that relationship, that hierarchy. So the sphere says, buy me a transformer, I want ice cream. And the sphere says, we are leaving. All right? So parent-child. This is a way to get things to move too. Now you might be thinking, how the heck does this relate to animating? How does this affect making things move? Go ahead.
Makes it so that way you want two things to move together. For example, car and wheels.
Exactly. Exactly. We want things to follow each other. And even when it comes to human beings, we want things to follow each other. Anybody play football? Any football players? If you're trying to tackle somebody, what does the coach tell you to keep an eye on? Hips. Hips and feet dictate direction, right? If my hips are pointed this way, I'm going this way. I can't go away other than my hips are indicating, right? A little hip demonstration for you. All right? Now, if my hips are going this way, Gesundheit, can my spine? A little bit, but eventually it's going to have to follow the hips. If my spine is going this way, can my arms go the other way? Again, a little bit, but they're going to come along behind. Your whole body is an enormous hierarchy. The hips tell the spine what to do. The spine tells the arms what to do. The shoulders tell the elbows what to do. Elbows tell the wrists what to do. Wrists tell the fingers and hand what to do. Does that make sense? Your whole body is a huge hierarchy. That's how we move. Make sense? Okay, so setup or rigging, not just objects, although wheels in a vehicle are a good example. Also the bones in your body. When I move my shoulder, my elbow and my wrist have to move. Does that make sense? Get a hell yeah? Okay. All right. So, if we go back to our door exercise, if I want the parts of my door to work properly, and I want it to pivot from the right place, I can do that because now I know all about pivots and I know all about establishing a hierarchy. So if I want these things to move properly with the door, I can create a hierarchy for it. I can make those things move together. I can use grouping, or I could also use parenting. If I wanted to parent this door, parent the parts, who's the parent and who's the child? The door is what? The door is a parent. And these two pieces are the children. So I can select the child first, shift select the door, edit, parent. Now when I select the door, this also lights up and they move together. But it still has the ability to do its own thing. Same thing here. I want this locking mechanism to be child of the door. I select the child first. Shift select the door, edit, parent. Now the door moves all the pieces and they all have their own motion still, their own ability to move and do what their function is. that make sense? Hell yeah? Okay, good. So this is hierarchy. This is setup. These are the baby steps for rigging, the process of building a skeleton that will allow you to bring characters to life because of the hierarchy. Just to give you an idea of what I'm talking about, this is a character with a rig on it. All right? The rig is basically a skeleton. The skeleton is composed of a series of joints. The joints affect and control each other using hierarchy. When you've got a hierarchy in place, when you move objects that are in that hierarchy, they all move together. All right? If I want things to move, I rig them. And I can build some cool controls on there to help it do the things that I want it to do. La, 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 la. All right? So point being, hierarchy, pivot points. That's what makes this thing go. Right? Here's the hypergraph hierarchy for this thing. And this is a medium complexity rig. But it's all nodes and hierarchy that make it go. Does that make sense? We're giving you the little pieces that take you to the bigger stuff. And again, with these simple ideas, which are, not overly complex, we can make things move. All right. Now, in terms of making things move together, you guys were able to get your door to work right? The handles and locking mechanisms? Okay. Because that leads us to our skill check for today's lecture. The skill, I knew there'd be excitement. In terms of your skill check, you guys are going to love this. Boop. We are going to use what we learned about hierarchy and pivot points to make the zombie kill bus function properly. All right, so this is a skill check, so that means I've got to set my project to my skill check folder. File, File, Set Project. Choose my skill check files. File, Open Scene, and I want my hierarchy project. And I open it. And you'll see we have this cute little bus. And the wheels on the bus go round and round, but they don't follow it all over town. So we need to fix this. So if I want my wheels to move with my bus, again, there's more than one way to do that. Let's say I want to do parent-child again. Who's the parent, the bus or the wheels? The bus is the parent. Because ideally what I'd like to do is be able to grab the bus and move the bus around and the wheels go with it. And that's always the key to figuring out hierarchy, is figuring out who's in charge, who's following who, and then that dictates the hierarchy you have to create. So if I want the wheels to follow the bus, but I still want them to spin around, then the wheel's going to be the child of the bus. I could also group this, but let's do it with parenting first. I select the wheel, because you always select the child first in the parent-child relationship. Then select the bus. Edit, parent. So now the wheel turns, but when I grab the bus, the wheel goes with it. Now if I want all the wheels to follow the bus, I can literally grab them all, hold shift to add to my selection, grab the bus, edit, parent, and now when I grab the bus, the wheels on the bus go round and round, round and round, right? And they follow that bus wherever it goes. That's what I want. But here's where it gets exciting. Look at the repurposed bus modifications. If you hit the visibility, boop, dun 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 dun, zombie killing fury. Ah! So what we've got is we've got this really cool armor here on the windows, so the zombies can't get in. You know, it's not ideal when they get in there with you, so that's not good. We got to have some armor on there. We got some we've got some big spikes here on the wheels so that we can clip any slow-moving zombies that are walking alongside us as we go careening through fields looking for zombies. And we've got this totally boss zombie slicing thrashing machine, saw blades. But the problem with it is it's not functioning quite right. Things are not moving as they should. And what we want to do is make sure that everything is behaving the way it should. So what I'd like you guys to do is figure out how this thing needs to move in order to make all of these cool accessories move with the bus and it can still do its job. So those swing arms need to move in a certain way. Those blades, that drive shaft, all that stuff has to move in a certain way in order to get the behavior that I want. Because if I can't raise and lower that, I can't get the tall and the short zombies. I have to be able to adjust both. So your skill check assignment for lecture 5, we are going to adjust the pivot points of the parts of the bus first. It's much easier if you do hierarchy first, pivot points first. Adjust the pivot points first, then set up a hierarchy that makes the bus work. Does that make sense? But do your pivots first. It's much easier if you do those first. All right? So that's your skill check. We want to see that you understand this whole pivot thing and this whole hierarchy thing. So make your bus functional, and then you'll be good to go. All righty. Any questions about the skill check? There's a layer, and that's directly under the channel box in Maya's layer editor, and you'll notice the leftmost empty box there. If you click it, it creates a V for visibility, and it works kind of like the eyeball in Photoshop. When it's not visible, you see nothing. When it is visible, you see whatever's on that layer, which is a great way to hide and show things when you're working, which does the same thing as Photoshop. Yeah? The hypergraph hierarchy is an orthographic window, so it works just like your front view and your side view. So there's no tumbling in there, but if you hold down the Option key and the middle mouse button, you get that track or dolly. If you hold down the Option key and the right mouse button, you get that zoom in and out. But if you select an object and you're in the hierarchy window and press F for frame, it will frame that node as well. So it's a great way to kind of jump around in there. But just like all the other orthographic windows, they all work the same. Does that make sense? Get a hell yeah there? Yeah, okay, I see you guys happily clicking away, so it's I know you're having fun. That's good. All right, any other questions? Anything else? No? Going once? Going twice. Oh, there you go. Mm-hmm. Yes, whichever thing you select last will be the parent. So, like I said, if there was 50 things and you selected all 50 of them, whatever was last would be the parent of the other 49 things. But you can have hierarchies within hierarchies, parenting within parenting, grouping within grouping, because if you think about it, you know, my arm, when I move my shoulder, my elbow has to move. But when I move my elbow, my wrist has to move, but my shoulder does not. When my wrist moves, all my fingers have to move. But my elbow and my shoulder do not. And all of my fingers move. Does that make sense? So you have hierarchies within hierarchies, much like grandparents are the parents of your parents. And you are the children. And your children will be below you. And it's sort of a chain of command. Circle of life. Circle. Anything else? No? Going once. Going twice. Oh, go ahead. It's always on twice. Somebody goes, I better ask. Go ahead. Yeah. Just the way it's set up. There's not really a difference. It's a function of, well, how do you want these things to move? Because if, let's say, for example, I wanted to use grouping instead of parenting on this bus. Let's say, actually, I'll open it up again. Hierarchy project. Boop, don't save. So let's say I want these wheels to move with the bus. I could also group them. I could select both wheels of, or all the wheels of the bus, as well as the bus itself, and I could group it. And when I select the bus, the wheels don't move with it. The wheels don't move with it. But if I select the group node that they're all under, right? Here are my nodes, all the wheels and the bus. If I select the group node, they all move together. Does that make sense? And the wheels do still turn, but I'm not grabbing the bus to make everything move. I have to grab the group node. Does that make sense? Okay, so it's how do I want it to work that makes you choose one over the other. Does that make sense? There's not one better. It's just, well, how do I want it to work? I can tape things together or I can glue things together. What do? I don't know. Is it going in water? Well, then I better not tape it. Does that make sense? Always, what do I need it to do dictates how do you go about doing it. Does that make sense? Yes. Is the, I'm sorry? Well, the swing arms have to move, obviously, so you can get the tall and the short zombies. The blades have to be able to turn. The question, oh yeah, each individual blade, absolutely. Absolutely. What's that? Probably, yeah. So you got to think about, well, which way should they move? You know, where's the pivot point on that? All right, cool. All right. Any other questions? These are great questions. I like all that stuff that's coming out. This is bonus information. All right, lecture 5 going once. Lecture 5 going twice. Going twice. Lecture 5. Sold 1712. Nope, it's too late. All right, so get that skill check done, get it turned in. I am grading furiously to get your week 1 turn in all graded up. There's a lot, but I will get through it. But keep working on your assignments, keep doing the best you can to complete your work in advance so you can get it looked at. And remember that I give you a ton of information on the actual activity in terms of what we're looking for, what you should name it, like all that stuff is on there. Do yourself a huge favor and take the time to read the activity for the turn-ins, because there's a lot of instructions on there that you need to make sure you're following in order to be successful with these assignments. And anytime you think you're saving time by not looking over the instructions, that's when you get the grade and realize maybe you should have done that different. So make sure you're reading the instructions first. You guys ever heard that story about the instructor who said, you know, there's a big long paper, make sure you read all the instructions before you begin, and there's like a whole boatload of instructions, and at the very end it says, do not write anything on this paper, just turn it in blank and you get a 100%. And like people who go through the whole test and at the end realize, oh, I should have just read that, I didn't have to do any of this stuff. That's an urban legend, I'm sure, but did it? That actually happened? Okay, that's a cruel monkey right there. But what I will tell you is more often than not, that doesn't happen. But the lesson of follow directions is a huge one, because I cannot tell you how ineffective you are as an employee in this industry if you can't follow instructions. That's the way you have to make what they want you to make the way you want to make it by the time they want it, or you're in trouble, you know. Where's that tank I asked you to build? I made a dragon. You want to see it? That doesn't happen. I mean, that'd be great, you know, if you just showed up to work. What do you want to make today, Steve? I want to make a dragon. Awesome. Here's your check. No, not even close. Not even close. But the sooner you realize that, the better. You know, you want to be a happy, productive part of the team that makes things happen. And then that's how you have longevity to your career. All right, very good. All right, well, thank you very much, everybody. That's all I wanted to talk about today. We will meet again on Wednesday and talk about more fun stuff. And I think we'll be getting into, materials. We'll be getting into materials and shaders, the first little steps towards texture components. So we're going to be learning all about coloring geometry and, oh, me too. Yes? Not in this class. It'd be awesome if I had time to really get into animation with you guys, and we actually used to teach that in this class, but we don't anymore. But you will get lots of animation in your classes that are coming up, because there's a whole chunk of classes on that as well, with some very talented animators. You're really going to like that stuff. But yeah, we don't really get into it in this one. But I'm glad you're interested in it and asking about it. Oh yeah, no, there's a ton of that stuff. There always is, absolutely. But like I said, just remember, anybody can make a tutorial. That doesn't mean they know everything about it, nor is that the only way to do anything. You know, and you just have to go into it with that mindset. Because I think oftentimes people look at those tutorials and they think this is the way and the only way, you know, and it's like, yeah, exactly. And you can't take it as that. Everything you look at is information, good, bad, whatever. You just have to learn how to pick the things that work for you and just add those to your utility belt of skills, and the stuff that's ridiculous, just let it go and realize that's just one person's opinion. Yeah, so the good and the bad of the internet is anybody who wants to post can. It doesn't mean they deserve to, as is evident by quite a bit of what's on the internet. All right, thank you very much, everybody. I will see you on Wednesday. Take it easy, have fun. See you then.